in my opinion, the types of tonearm measurements that are helpful, that tell you how a tonearm will perform its fundamental job of holding that cartridge infinitely still, are either not being done or not being shared.
So, I think that these instruments are so important to measure from the designer's point of view, because they're checks and balances. But when it comes to the ultimate design, they're gonna help, but they're not the final answer, if you know what I mean.
So welcome to the channel. Thank you very much for joining us. I'm David from Origin Live, and this is my dad, Mark, who is our company founder. Today, we are very excited because we have our first ever guest, the one, the only JR Boisclair. JR is the owner and the principal product developer at WallyTools. And WallyTools make a fantastic suite of alignment tools for your cartridge, which help to optimize and align your cartridge just right. And alongside that, JR also offers his services to analyze cartridges and also advise on setup for audiophiles, because some of these cartridges we have cost more than our cars. So we might want to do the utmost to get the most out of them. And yeah, JR is just a wealth of knowledge on cartridges. So he's also a wealth of knowledge on tonearms and all things vinyl playback. So today, our question, we've just finished a series on tonearms, and we're curious about your thoughts on, is tonearm performance measurable?
Well, thanks for having me, fellas. It's exciting to be here talking to two guys who I really respect in this industry. Okay, is tonearm performance measurable? That's the question?
Yeah.
Yeah, okay. So, yes, I believe it is. However, not in the way that we've been classically measuring it. So the specifications, the measurements that are typically offered for tonearm A versus tonearm B or tonearm C often include the effective mass, for which you're supposed to use the lookup table and determine that your cartridge and tonearm have a match with each other.
So this is compliance.
Compliance, yes.
Okay.
Because the cartridge and tonearm together make a spring system, and the traditional thinking is we got to keep that spring system within 8 and 12 hertz, and I reject that claim almost in its entirety, which we can talk about later. But to try to stick to your question here is tonearm. See, tonearms are supposed to serve as a stable platform for the cartridge. They should add nothing to the signal. They should just get out of the way from having the cartridge do its very difficult work of remaining stable over the mean position of the groove. Now, the mean position groove, depending on what amount of time you're looking at in this snippet of travel time for the stylus from point A to point B, is a pretty wild ride. So it's an incredibly difficult job, and for a tonearm to hold the cartridge totally stable, all tonearms fail at this job. Every last one of them, to greater or lesser degrees. And it's the tonearm designers who understand why they fail that I think make the most successful tonearms. To understand what is at stake here with respect to how unbelievably sensitive that cartridge is to displacements of the stylus down in the single-digit nanometer region. And there's 1 million nanometers in the thickness of your credit card, just to put that in perspective. But the types of, in my opinion, the types of tonearm measurements that are helpful, that tell you how a tonearm will perform its fundamental job of holding that cartridge infinitely still, are either not being done or not being shared with the public. What we don't want is for that tonearm to be displaced by the groove content, only the mean groove position. Let me explain what I mean by that. So as the stylus is wagging about in the groove, that's a lot of energy that's being transferred, and that energy, it's a fixed rigid system from the stylus to the cantilever to the coil former. It's all a fixed rigid system, and it pivots behind the coil former. And we want that location, the pivot of that that stylus coil former cantilever system, to remain infinitely still. That's the tonearm's job. Because as soon as you allow that pivot location, the pivot of the cantilever, to move relative to the groove, then you've created a signal. It's a mechanical distortion, it's an electrical distortion. And it becomes part of your noise floor. All of us live with this to greater or lesser degrees.
Yeah.
But better tonearms allow less displacement, allow less displacement as a consequence of all that energy wagging about, the stylus cantilever assembly wagging about. And
in theory, the only way, sorry to interrupt, in theory, the only way you could control it is with something like a 10-ton weight on the head shell, because you've always got inertia to cope with, haven't you? That stylus has to get its kick, or so its foundation from somewhere, and because the head shell is only a relatively small mass, it's going to move it, and so it's a very difficult problem to solve.
You're absolutely right. The perfect tonearm would have infinite mass and infinite rigidity. that would be very practical.
And if we could move it, that would be great.
You know, that would be perfect if we could move it. But that should be our starting point. All right, that should be, because that is where signal is won or lost. And so the way to measure how well a tonearm is doing as a consequence of keeping the cartridge still can be done with very sensitive accelerometers, lightweight and sensitive accelerometers, or laser interferometers. We own both in our lab as part of our lab equipment. But laser interferometry is more sensitive, and it's a little more difficult, the setup. And I can even show you some examples of what it looks like for a tonearm from better to worse. So yes, we can measure tonearm performance. It's all a consequence of not allowing the displacement. But to your point, and you're 100% correct, Mark, some displacement has to happen. Then the next question, because we're not going to be infinitely rigid, infinitely heavy. So the next question is, okay, once that energy passes the pivot point of the cantilever and gets to the head shell, what happens to it? Now, if that energy, as a consequence of the material and the design and mechanical impedances in the head shell area, are such that the energy stays there and doesn't evacuate as quickly as possible, as far away as possible, then the cartridge is going to reread that information. And it'll be, again, part of your noise floor, right? And it's not a noise floor we notice. It's not like pops and crackles. It's not tape hiss. It's just less of everything. And
it's transient performance. It's
transient performance. It's a sense of resolution. It's a sense of distance, separation between instruments, believability of the sound stage, a sense of ambiance. It's a deterioration of everything, which we all suffer from to greater or lesser degrees, but aren't even aware of it until we've remedied the problem somewhat.
Yeah.
Right? It's one of those audiophile things. You don't know what you're missing until you have it.
Yeah.
Yes. Yeah. And it's tough. It would be. I did a video. The last video I released was on measuring tonearm performance, or sorry, not measuring, comparing tonearm performance, controlling the variables. Tonearms are the most difficult product component in the audio chain, in my opinion, to honestly and fairly compare the performance between A and B. Very difficult. And I know you guys know this. You've been spending years with plenty of effort trying to determine is the change I just made in tonearm B an audible improvement for us.
All I can say there, it's hard enough to compare the performance of speakers, hard enough to compare the performance of amplifiers. I know an amplifier designer who said he's never known what an amplifier is going to sound like by looking at the specifications.
Yeah.
He's a designer, so
Yeah.
if you're saying tonearms are even worse, that is really saying something. Yeah. And I believe it, actually. I believe it. It's
very tough.
Into examples of how you can get perfect measuring speakers that sound completely different from one another.
Sure,
it's so I think that these instruments are so important to measure from the designer's point of view, because they're checks and balances. But when it comes to the ultimate design, they're gonna help, but they're not the final answer, if you know what I mean.
Yeah. I could take one tonearm, and just by changing the torque on that arm, that is changing the anti-skating setting a little bit, I can make it sound very different, right? Yeah. But most people, when they're listening, and that's just one way to make a tonearm sound different, right? But most people, when they're measuring, when they're evaluating whatever in their system, aren't even measuring torque. Okay, and that's just one parameter. How about stylus yaw, zenith error, right? If you've got two different cartridges with two different zenith errors on each of them, everything else being equal, they're going to sound different, right?
Yeah.
I could go on and on about the list of things that will contribute to performance deterioration. And if these variables aren't controlled for, then you don't get an honest window into the performance of what you wish to understand the performance of. Yeah.
With you. You've got a very interesting graph there on the wall. You're at your measurement of a speaker cartridge head shell, I think is.
I can share this on the screen. So let me share it with you here, because I've got it here. Okay, are you seeing the graph?
No. Yeah. Here we
go. Okay. So this was a measurement we did related to a product we created. It's a head shell upgrade for the Kuzma 4-point and Ref 313 tonearms. It's called a Colossus head shell. And what we did is we attached a very, very sensitive accelerometer to the side of a Kuzma head shell, which is an excellent removable head shell, by the way. So there's nothing wrong with it, but we just wanted to make a better one. And we measured what is the horizontal displacement of the head shell when playing pink noise. And so the red trace, that's the Kuzma head shell. And you'll see it's higher in noise level across the entire bandwidth than our Colossus, which is the black trace. Now, I'm not sure if you can see my cursor here, but this spike here, that's 100 hertz. That is turntable rumble. That wasn't going anywhere. So that was the same on both Tonearms. And then you might ask, well, what about some Tonearm manufacturers that they articulate what the resonance is of their arm wand, which is perhaps helpful. Actually, I do think it's helpful because the higher the resonance frequency of their tonearm, the more rigid you can expect something is. That's not universally true, but generally true. And you can see what are like the other peaks. You can see what are likely some resonant modes of the arm wand itself. Now, because you'll notice that there's a downward frequency shift when we for many of these peaks when we put the Colossus in. That's because we've added mass. As you add mass, you're going to lower the resonant frequency. So this peak was shifted to there, this peak was shifted to there, and so on. But a dramatically lower a noise floor. So this is the type of measurement. And again, this was just measuring the horizontal displacement of the head shell. Remember, displacement is what we don't want. Displacement in consequence of groove content. So the lower, the better. There was
so
another.
This means, so horizontal displacement is literally how much the cartridge is moving.
That's right. Yeah.
With
in this case, shell. Literally, it's the head shell. We could have glued the accelerometer to the cartridge too, but I really wanted to measure the head shell directly. Here's the noise spectra with comparing just a non-modulated groove. This is a non-modulated groove. Now you'll see the overall noise is much further down. We're down in the minus 80 dB range, but and the lower frequencies, that's where things get worse, and that's all related to wow and rumble, right? Yeah, but we're getting down into the electrical noise floor here too. You see these really, really narrow black spikes? That's electrical noise. So we know that we're really, really getting low here. Again, this is a non-modulated groove. So even in a non-modulated groove, you can see the improvement in performance of having higher mass, higher rigidity, which is what the Colossus is: higher mass, higher rigidity.
This may sound a little bit of a silly question, but I'm thinking here of some of the readers who may read the kind of the lab reports of things like Hi-Fi News, and the chart tends to have a kind of big peak in the middle, like the Matterhorn, at around the kind of 3K region. What are they actually? I mean, you can see that, but
we're just thinking about
the one, yeah.
Oh yeah. Well,
so what are they measuring? What exact measurements are they taking to do that?
So I'd have to study more about what they're doing there. What we see there is amplitude, frequency, and time, right?
Yeah.
And are you saying that on most of their measurements, they're getting this peak at 3000, regardless of the cartridge?
No, it definitely varies,
but it does tend to look like that most of the time.
But this is kind of one of the only published measurements that I guess the consumer has in something like a Hi-Fi News, or I think Hi-Fi News, I think maybe Stereophile did it as well.
They did, not anymore. Yeah.
How useful is that kind of data?
Well, so this is cartridge measurement, right? Not tonearm measurement. Yeah.
No, this is
it's an accelerometer on the head shell.
Oh, it is an accelerometer on the head shell. Okay.
Yeah.
All right.
Yeah, this is a tonearm. This is a tonearm analysis.
Oh, okay, good. Well, so and to do that in time too, that's very helpful to see how long it stores energy given an impulse. Okay, but in the just by way of reference, the graph I showed you before was obviously with a constant signal, so time isn't of consequence. It would be a mess. So the scientific part of me is to think, okay, well, I want to see the protocol for the setup to make sure you haven't introduced one of the many ways to screw your data up by having a poor setup protocol. I think this, if it's a responsible setup, I think it can be very helpful, right? Now, let's say we measure a tone arm and it looks like this, and it's got this 3000 hertz energy that it's carrying. That one looks to be really narrow in its spectrum, which is less problematic than if it were a wider cube. But then you might ask, well, how big of a problem is that? Am I going to hear that? And I would answer that with the typical audiophile experience. Well, if we can control for it and remove it, and you can hear A and then B without it, will you hear the difference? So I can't say for certain, but our hobby is filled with opportunities to remove noise. So the more noise we remove, the greater the possibility of getting a truer representation of what's in the groove, right? So I'm glad they're doing these, but first thing okay, so that's a tone arm measurement. I would want to know which direction, what's the stimulating signal, how are they attaching the accelerometer, where exactly are they attaching the accelerometer, I know this sounds crazy, but how much torque did they put on the screws holding the cartridge to the head shell? Actually matters. It can change the results.
Oh, yeah,
we agree.
yeah,
We agree on that
yeah,
for sure.
Yeah.
Interesting.
And so yeah, I see a reason to value some of this, but whenever I issue graphs like the one I have, which I've done in videos, I make the disclaimer, and so I should do it here, that just because the Colossus measures better than Kuzma doesn't mean Kuzma sounds bad. The Kuzma head shell sounds wonderful. Like I said, it's like perhaps the best removable head shell I'm aware of on the market, right? If you want a removable head shell. Ideally, you wouldn't use a removable head shell, but I needed it for our purpose. Yeah, ideally, you would not want a removable head shell. This is true, because it's another joint, another joint in what should be a highway for that energy to propagate away from the cartridge as quickly as possible. It's another boundary, another mechanical impedance. Okay? So yeah, I'm just because something measures better than the other, I'm not claiming that if you own the one that measures worse, it's going to sound bad. I would never say that. I'm only interested in exploring the boundaries of performance of mechanical transcription. That's my only interest, right? So with that comes a few rules, right? If I'm exploring the boundaries of mechanical transcription, then I'm not going to have wood anywhere near my cartridge body or toner. It's just too lossy, and it adds too much of its own characteristic. It editorializes. Doesn't mean it's going to sound bad. It can sound wonderful. Yeah, I own a couple wood body cartridges, and they sound wonderful, but they'll never have the clarity, separation of instruments, the sense of attack, and decay and low-level noise floor I can get with other same type products that are more rigidly designed. Yeah.
Yes, it's always the big dilemma, really, because it's like that with cartridges. I mean, I won't name the cartridges, but some cartridges can give you fantastic detail, fantastic dynamics, but they don't have the harmonic kind of, for something like jazz, they don't have the harmonic content that are more romantic. I say romantic, but it's just much easier on the ear, sounds more natural in a certain frequency range. but for the extremes, it's not as good. So it's often a kind of trade-off and a balancing act between the various factors.
Yeah, you're right. The one thing I would caution, and I've heard that many times from clients, the one thing I would caution people when they mention this very true statement that you've just made is that, well, let me tell you this. Yeah, as you mentioned before, one of the things that keeps me busiest is doing cartridge analyses in the laboratory, where we analyze your specific cartridge for the 4 angular errors, and then provide a corrective shim for you to correct for 3 of them, and then a method to correct for the 4th. When I have clients who own multiple cartridges, who send them to me for analysis, before they send them to me, I ask the question, why do you own multiple cartridges? And the answer that comes back is typically something like the following. Well, I like cartridge A because it's got great imaging and sound staging. I like cartridge B because it's got great dynamic slam. Cartridge C, I love it on jazz. It's just got that warm thing going. I just love it. And so they like it for different, cartridge A through Z for different sonic characteristics. When those people send me their cartridges, I try to get feedback from everybody, but particularly guys with multiple cartridges. They respond with consistently, and I mean universally, they tell me 2 things. 1, every cartridge sounds better than it did before. And 2, they all sound more alike than they ever did before.
Right.
So
Okay.
they begin, they almost universally then go down a journey of really only listening to 1 or 2 cartridges anymore, because now they're able to determine which ones are really performing the best. The moral of the story is a lot of what we hear from our cartridges are the angular errors. A lot. They are editorializing. And this is why, and I've got to believe that, and this is, I think, partly why there's so much mysticism around cartridges and cartridge marketing, is that I got to believe that some cartridge manufacturers don't fully understand why 3 of the same models will sound different from each other. I got to believe that many of them wonder why that's the case. Many of them. And
Well, it's tiny manufacturing errors, isn't it?
Yes. And they actually amount to quite a lot. Yes. And I can tell it's demonstrable. It is demonstrable. Repeatedly, not just sometimes. So, and yeah, in the cartridge industry, actually, and this is a whole other topic, cartridge industry isn't actually making cartridges to mimic the transcription characteristics of a cutter head. Like, for example, VTA on the average cartridge is 9 degrees too high, versus how cutter heads actually have their vertical modulation angle. Stereo, of course, is the only place
they
that vertical
they know that as well, some of them.
JR, thank you so much for your time. It's been really informative talking to you, and I feel like every time we speak, I learn something. I feel like we all benefit from your great wisdom on these matters.
Thank you.
So thanks very much.
We benefit from your tonearms.
Too right. So thanks for everyone at home for watching. That was just us talking about whether tonearm performance is measurable. There is so much that we could chat to JR about. Whether you guys have questions that you would maybe like us to ask in a future video with JR. We've also got other topics we want to cover. Please comment them below. Like and subscribe to our channel and also to JR's channel. This is hopefully going to be shared and collaborated with on JR's excellent channel, which is just a gold mine of information on cartridges. JR's content is supremely underrated and deserves a lot more views. So if you're from our channel, explore JR's channel and hi JR's channel if I'm on your channel. Okay, that's all. Thank you so much, and keep listening to your music, keep enjoying your music. All the best.